right, for conditional probability, it contains a condition that limits the sample space. The sample space is your total number of choices. And you'll see hopefully when we start doing these, the condition they give you tells you what the bottom number is going to be, what your total number of choices has to be. We should recognize this little second part right here, probability of B, given that A already happened. Like I said a minute ago, for conditional probability, the total number of choices comes from the condition that it limits you to, and that'll make more sense in a minute. The actual math version is the bottom down here. Probability of B, given that A happened, is the probability of A and B, you should know how to do that, over the probability of A. Alright, first thing I would do on something like this, if they do not give you the totals, write in the totals. So for example, how many people said yes?
13.
13 people said yes. You got 8 and the 5. How many people said no?
13.
13 there. How many were female?
14.
And how many people were male?
12.
And then you got your total of 26 people overall. That's what I would do first. And really, I don't know that we'll need the 26, but we will need the others. All right. So for conditional probability, like this first one says, probability of owning a pet, given that it's a female. So the only people that I'm really looking at are the females.
So 14 over 26.
Now, the only people I'm looking at are the females. How many females are there?
14.
There's 14. There's my bottom number. Of those females that I'm looking at, how many own a pet?
8.
So there's my answer. Simplify that down. 4 over 7. You got your answer.
That's it.
Probably.
The conditional eliminates stuff you've got to look at. So the second one, male, given that they don't own a pet. So where am I starting?
Don't own a pet.
I want to know how many people don't own a pet.
13.
So there's my bottom number. Of those that don't own a pet, how many are male?
6.
There you go. All right, see if you can finish those other ones. All right, so for probability that don't own a pet, given that they're female, start with
Female.
start with female.
You want me 14?
I got 14 females. Of those, how many do not own a pet?
6.
Simplify that down.
3.
Got your- Go back over here. Probability that it's female, given that they own a pet. So start with
13.
own a pet. Well, 13 own a pet. Of those that are female,
8.
got 8. The last one is just written out in words instead of the symbols. Probability that the person owns a pet, given that the person is a female. Where do I start?
Female.
Start with female.
14.
So there's 14 females. Of those, own a pet.
8.
So this was actually the same thing as that. You got one with the symbols and one with the words. It's the same problem. Alright, again, first thing I'm going to do is fill in the chart. There's 12 there, 14 there, 14 there, and 12 there. You can put the 26 for the total down here, but really we don't need it. Alright, probability to wash dishes given that they are male. So I'm starting with male, which is 12. Of those, how many did wash dishes?
4.
No. Yes, for male is 4. Alright. Didn't wash, given that they're female. So I'll start with how many females I have. That's 14. Of those, how many did not wash? Should be the 6. So we get 3 over 7. Alright, next one, probability of female, given that they did wash the dishes. So how many did would be 12. Of those, how many are female? 8. Should be 2/3. Probability of a male, given that they did not. So I'll start with how many did not. That's 14. Of those, how many are male? 8. 4 over 7. Last one is the words. Probability that a person did not wash dishes, given that they are a male. So where am I starting? Males. Males are 12. Of those 12, 8 did not. 2/3. All right, any questions? All right, again, the first thing you need to do is get the totals. What is the total for recycled?
60.7.
All right, not recycled.
156.6.
All right. And then come over here for paper,
83.8.
and then metal,
16.6.
glass,
12.
12.5.
and
83.1.
so again, do that first. Do not try to work a problem out unless you have that. Then I can say, okay, give the probability of plastic and it's not recycled. So I start with not recycled, which is,
26.20.
that goes on the bottom. Then I say, well, how much of that is plastic?
20.4.
Now, as far as the answers go, if we have any like this, you can leave it as this. I think what EOC would have it is the decimal version of this divided out. So, when you look at the answers, if you have one like this on the EOC, you check the answer. If the answer is like 0.17, then you know I've got to divide this out. If it gives you the fraction, then you just match up the fractions. Does that make sense? So, depending on what the answers are on the EOC, if you have one, you either leave it like this or you divide it out.
You got 20.4, but yeah, so it does it say not recycled? So you don't do the
No.
whole plastic?
It's got to be in the not recycled part.
Okay.
You see what I'm saying? So all I'm checking is, okay, not recycled is here. Of that not recycled, how much is plastic?
20.4.
Right.
Okay.
So the same thing here. Probability that it's metal given that it's been recycled. So I go to the recycle part, that's 60.7. Of that, how much is metal? 6.5. Same deal, if you need to divide it and get the decimal answer, do that. Probability recycled given that it's paper. So I start with paper is 83.8. Of that paper, how much is recycled? 34.9. Probability not recycled given that it's glass. So I'd say 12. Of that, 9.1, eh? Oh, not recycled part. Probability recycled given that it's other. So I start with the other, which is 83.1. Of that, how much is recycled? 15.3. Not recycled given that it's paper. So I go back to paper, which is 83.8. Of that, not recycled is 48.9. The last one, the words, probability of glass given that it has been recycled. So I start with the recycled. Of that, recycled is 60.7. Of that recycled, how much is glass? 2.9.
You're going to answer what says to it.
All right, first one says 74% of high school seniors will go to college. 32% of those will live at home and go to college. What is the probability that a student will live at home given that they are going to college? So what is my condition? Well, what is my condition? Going to college. What is that percentage? 74%. All right. Now I can't put percentages in there, so I have to put the decimals. So 0.74 instead of 74. All right. Of those 74 that are going to college, how many are going to live at home? Well, it tells me 32%, so 0.32. This one we probably need to go ahead and divide out. I doubt they would have this type of question with decimal fractions. So 0.32 divided by 0.74 is
16 over 37.
huh?
16 over 37.
0.43.
Probably the decimal version is what I'm thinking. All right, second one says 27% of people like baseball and will go to a Major League Baseball game this year. 53% of people like baseball. What is the probability that a person will go to a Major League Baseball game this year given that they like baseball? So my condition is they have to like baseball. Well, the liking baseball is 53%, so that's 0.53. And of that 53%, 27% will probably go to a game, so 0.27.
Is equal to 0.51.
All right, now the last one we've got to make sure we read right. 43% of high school students like math. Of those that don't like math, 67% also don't like science. given that a person doesn't like science, what is the probability that they also don't like math?
Don't like science is gonna be the bottom.
So in this case, 0.67 is my bottom, because that is the condition that they have to not like science. All right. What is the probability they also don't like math?
57.
Where does 57 come from?
43.
This is 43% like it. I need how many don't like it. So I do 100 minus that 43. That tells me 57% don't like it. So 0.57 would go there, and then you get my decimal version of 0.85.